So on the first glance of this picture, what are all the things come to your mind? Okay, buttermilk extraction. That's good. That's what they're doing. Essential material is extracted. Good. You people helping me to get into the point in a quick way. Okay, any other views? I just wait for one more some 30 seconds and I'll just get into it. Okay. So, separation of needed product from the raw material. Wow, I'm getting interesting answer. Extraction of new thing from pre-existing things. That's great. Okay. Now, all your views are good. Okay. Now, with I have displayed this picture in another view. I tell you what that view. So from this picture, you see that from the curd, right? In the curd, they are using an wooden instrument, right, to do some process. So at the end of the process, they were interested in getting your butter, right? So they do it and get the needed one, right? This is the core message conveyed from this picture. With this understanding, I just want you to explain the difference between your internet and world wide web. Okay. So as of now, when we speak about internet, the very first thing come to our mind is World Wide Web, www, right? But there is difference between them. Actually, your internet is nothing but global network of networks. It is nothing but network of networks, and your World Wide Web is collection of information that you can access. You can access through that internet. See, this is like your code. It is like a global of networks, right? And you use any of the protocol, right? You use any of the protocol like this wooden instrument to access the needed information that can be accessed only through this internet. That is from like you access the needed information using your protocol from this instrument from your through your internet. This is what the basic difference are. So your internet is infrastructure and your world wide web is nothing but the service that runs on the top of this infrastructure. I tell you why we are seeing this difference, because this is the essential difference that we need to understand to proceed further. So from now onwards, when you hear the word internet and world wide web, both are different. Internet is infrastructure and you make use of this infrastructure to gain the need to access the needed information. That is your world wide web. Is it only service presented? No. You're using your internet, you have variety of service. One such interesting service is your email. When I say email, you should not think about your Gmail. You can think. See, for Gmail also, I'm typing www.gmail.com. It's not that email service can be accessed without your World Wide Web. That is example is your Outlook, right? And I will show you another service using your internet. That is your file transfer protocol. For www web, you use your HTTP. In the same way, for file transfer protocol, you use FTP. I hope this FTP you could have used in our colleges to access the NPTEL materials. We have a file server through which you can access your NPTEL materials. I will show you how you can do it from make it use of your FTP from the system in today's session. Then this is the first thing I want to show you from the picture. Then the second thing is this is the picture of curd, right? And this term curd has an important influence in your application level protocol. CURD means create, read, update and delete. Whatever application level protocols, right? Whatever application level protocols you design, or any databases you design. And as of now, I skipped the database part. That is not our interest. So any HTTP protocol, or sorry, any application level protocol should have methods, right? It should have methods to support this CURD operation, right? We used to say all the protocols will support this CURD operation. So what is this CURD operation? Your protocol should have method to create a resource, to read the resource, to update the value of the resource, and to delete the resource, right? So with this basic understanding, we will get into today's session. Okay. Now, I told your www is the world. You know what is World Wide Web, right? Okay. So what does this web service means? It is a standard medium or a standard way for communication between client and server application through World Wide Web, right? You can have communication. Now you know what is client and server, right? And for communicating between client and server, you have different ways. It is not that you have to use your only your triple W, right? If you use that, then you call that service as web service. I'm not getting into other types of services, right? And again, through your World Wide Web, the way you provide this web service, you have variety of ways, but we are going to concern about only one way, right? That I will, for that, you consider this is my application scenario. I have a client application. That is, I am designing one application and that want to work with, that want to interact with my Facebook and Twitter and any social medias. But I know that the language written, the applications, these applications were written in which different languages, and they may run in different platform. So how do I write a client application? This is the scenario. Right now, you have one architecture called REST, representational state transfer. This is like your HTTP, but you include your state property. It is the simple or energy constrained version. So if in simple words, you understand, if I provide my web service using my REST architecture, then I call that service as RESTful web service. At this time, I put a stop and then I tell the story again. If the client server application make use of my World Wide Web, then I call it as web service, right? And then if the web service make use of my REST architecture, then I call it as RESTful web service. Why I should go for REST architecture? It provides interoperability between computer system. What is interoperability? Your services can run on different languages. I mean different programming languages, and it can be present in different platforms. That is your operating systems, right? Now, actually, the underlying protocol for this REST is your HTTP. As I discussed, it can be used on various programming language and environment. Now, we can answer the question for the scenario what we seen in the previous slide. If I want to develop a client application, do I need to want to know what are all the social media application I'm going to interact? Do I need to know the languages what they used for development? No, it is not the case, because your social networks provide RESTful web services. They provide APIs through your RESTful web services, so you can easily make use of them to make an interaction. That means this Facebook, Twitter, and Google, they develop their application using your REST, so you can easily access them. We are not going to get into detail with this because this is to have a understanding, and why I picked this example means this is the things you use it daily, so you can easily remember that. Why we have this introduction means today we are going to see a application protocol, CoAP, Constraint Application Protocol, that makes use of your RESTful web service. To appreciate the RESTful web service, I had this introduction. With this introduction, we will get into our today's agenda, right? Today, we will be first discussing what are all the communication patterns supported in my IoT. Then what is Constraint Application Protocol? Then advanced message queuing protocol. We have already seen one kind of a protocol in the previous session. Then what is your low power wide area network? For this, I will just show you a YouTube video, right? Each day I will be showing a 3 to 5 minutes video on a particular connectivity protocol, and at the end of the after 3 or 4 session, I will consolidate and give you the needed information, right? If you have it in a single day, it will be difficult to understand each and everything, so I have decided one day one connectivity protocol. So today we will be seeing LP1, then we will be discussing about your Bluetooth, right? That is what we use it. We are already familiar with Bluetooth, so we will discuss Bluetooth and what is your low energy Bluetooth, right? This is the agenda for today's class. Now we will get into the communication pattern. Okay. So what do you mean by telemetry? Telemetry is nothing but you want to flow the information, right? You want to give information to other devices conveying your status. You are not going to give to a particular device. You just put it in a channel or a basket. Whoever interested in that information, they will come and pick it. That is your telemetry type. This is what we have seen in your message queuing protocol. Then what is inquiry? I am interested in the status of a particular device. Then I post the inquiry and get back the information, right? So I may inquire for multiple devices, this one to n. Then command, I'm passing command. I just pass command to one device to perform the things. Normally, this comes under your sense. You inquire from the sensor and you pass commands to your actuator. I hope you remember what is sensor and what is actuator. Can you please write your understanding in the chat box? What is sensor? What is actuator? Just a small recall. Then I will proceed further. Super. Okay, in simple words, it is an input and it is an output device. It sends environment, sensor sends the environment, actuators responds to the commands received from the user or the environment. Right. Now, notifications. The notification is nothing but you know what is notification. If it is nothing just like it will be used in terms of alerts, right? So this kind of communication patterns are available in your IoT. Now, we will see about constraint application protocol. This is why the word constraint. Constraint in the sense it consumes less power. This protocol consumes less power, and again how it and again it takes only little amount of bandwidth, right? It takes only low bandwidth. So you call it as constraint application protocol. Basically, it is like your HTTP. Then it is mainly meant for your machine-to-machine applications. Your CoAP is mainly designed for your machine-to-machine applications. Okay. So how the request and response will be? See, this is again a machine and this is again a machine, right? Okay. So when I send a request, I send it in terms of this way: the name of the protocol, right? The name or the unique name, that is I'm interested, the port number and the name of the device and the parameter which I want to measure. This is how I send the request. This is the request pattern. Then I receive response. From this you can understand your COP operate in which pattern? Request response pattern, right? Okay. As it is based on HTTP, like HTTP, you have your get, post, put, delete methods. Apart from that, you have one more method called observe. You periodically observe the status of your device, which is not present in your HTTP. And then again, the method calls can be conformable and non-conformable. From the word, you can say conformable means you confirm that you receive the message through your acknowledgement. And non-conformable means the receiver will not send any acknowledgement of receival of message. That is what your conformable and non-conformable. And again here you can reduce the number of media types you are going to pass. Yes, I'm getting over that. The next slide is what is difference between CoAP and your MQTT. Just wait for one more slide. I'm getting to that. Okay. Here comes. So what is the difference between your CoAP and MQTT? Okay. The full form you are not interested. The model. The important thing is what kind of communication pattern it uses. It can use either a request response, and even publish and subscribe is possible in CoAP, but you need to have some extensions. We are not going to see that. MQTT, it is only supports your publish and subscribe model. And your CoAP supports RESTful architecture, but it is not supported by your MQTT. Then for transport protocol, it preferably uses your UDP, but it uses your TCP, right? And UDP can be used for the extended version, and all those extension versions we are not going to see. We are going to see only the basic models. Then the header size. It has more bytes when compared to your MQTT, and the number of message type and the mode of communication both supports your asynchronous mode of communication. Then relating to your security and all those things from this, and you can have more, you can appreciate the understanding more by just referring this. I have taken this information from this websites. The basic thing what we understand from this comparison is your MQTT is better than CoAP in most of the application because it consumes less number of bytes. When you go for CoAP means when there is a need for request and response scenario, right? Where you need request and response scenario, you go for your CoAP. I think I have answered your question. Okay. The next is your advanced message queuing protocol. Okay. What is advanced message queuing protocol? Whenever it comes the term queuing, it means that you are going for an asynchronous mode of communication. And here you have one term called binary protocol. What do you mean by binary protocol? If the protocol provides a way, or it provides a way for passing information in plain text that can be readable by the user, then that is, you call it as text level protocol, right? and if it sends information in zeros and ones, and which you cannot read it in a read you cannot get it in a readable format, that you call it as binary protocol. At this stage you should not get confused. See, the communication always happens in zeros and one. Then what is this binary and text readable form? The thing is, when you pass in physical layer, right, when you pass it in physical layer, it happens in zeros and one, right? But when you pass it from upper to lower, when I want to trace it, right, when I want to debug it, or when I want to trace it, what kind of information is going on the packet, I have options for picking the packet and reading those values. We are not going to get into that, but you have options for picking the packets and reading the values. If I pick the packet, if and I am able to read it in a textable format, then it is text level protocol. That your HTTP is a very good example for that. And your AMQT is a binary protocol. It transfers only in zeros and one. That means it is highly suitable for machine to machine communication. And it is suitable only for machine to machine communication. Right. Okay. How it works? Again, it uses publish subscriber model, but here you have two terms called exchange. You have two terms called exchange and queue. That is, the first step, the publisher and consumer has to exchange their name. The first step is they have to exchange their name. Then your consumer will create a queue so that they can pass information through the queue, right? Then the messages received by then the messages received by that exchange will be mapped with the queue, because your consumer can create more than one queue with different topics. So binding of your queue with the exchange, you call that process as binding, right? And this message exchange can happen in different ways. Either it can happen directly, fan out means one to many, right? One from one producer, different consumer, that is one to many, or by means of topic, or by means of header. By default, it uses your TCP protocol, right? I repeat the process. First, you exchange your names, then your consumer creates queue, right? You can have more than one queue. Then there should be a binding between your exchange and queue for information transfer. So this is the pictorial representation. You place the message, right? Through binding process, I identify with which queue this message is related. How it identify means it will check for the topic and you pass this information, right? Okay. So in summary, what are all we have seen? Four types of, actually you have many application protocols. We restricted our discussion to four protocols, and these four are the widely used protocol and mainly for machine to machine communication. Whatever protocols we will be discussing will be mainly used for your M2M communications. So your MQTT, it mainly uses your TCP transport protocol. Your constraint application protocol uses your UDP. Then your advanced messaging queuing protocol uses your TCP, and same way your XMPP uses your TCP mainly. Right. With this, we put a stop for our discussion on application level protocol. Right. Shall I move for the next one? I am expecting the response on the chat box. Yes. Okay. Fine. Good. Okay. I will show you a video that helps you to understand why you have why you have varieties of low pass protocols, and in which protocol I have to pick based on the need, and there will be a short introduction on low power wireless area wide area network, not wireless, wide area network, right? You just carefully watch this video. Why I have picked this means it is highly informative. Lot of information has been packed in a minimum time. I just play it. Are you able to view the video? It is audible. If it is okay, I just play it. No, it is not audible, right? Whether it was audible, I have just stopped now. Is it audible? So that okay, okay, not audible. It is not audible. Okay, I play it again. You just type me if it is audible or not. No, video is lagging, not audible. Okay, okay. Just give me a second. I will just cross check it. I will directly play the video so that it would be better. Now is it okay? No. Uh, Okay, I will just post the video link so that you can watch it, right? If it is not audible, I will just post it. You can watch it over there, right? So we will move for the next one, right? Okay. Uh, I will post you the video, and in the next class, at the beginning of the session, we will discuss the points what you have inferred from this video, and we will start with the agenda for that session, right? Okay. Now I am moving for your next thing, your Bluetooth. Before we get into Bluetooth, we just want to know what is ISM band. You could have frequently heard the word ISM. It is nothing but It is the band, it is an unlicensed frequency band which can be used for scientific, medical, or industrial requirements. Right? It is an unlicensed free band available for use, and this range is mainly used for our low range communication devices like your Wi-Fi, Bluetooth, and all. Right? Normally, we have from 2.4 gigahertz to 2.5, and this frequency bands differ from different regions and permits for different countries, but the worldwide is 2.4 gigahertz band. And for further discussions in our for our low range communication protocols, we will be discussing the protocols that operate in the range of 2.4 gigahertz, right, within 2.4. Okay. The example is your microwave oven, cordless phones, and so on. With this basic understanding of your ISM band, today we are going to see about our Bluetooth devices. So what is Bluetooth? Okay. Bluetooth has an it is a standardized protocol. The standardization is IEEE 802.15.1. Okay. 802.15 standards is meant for wireless area network, and point 1 is meant for your Bluetooth. It is a secure protocol. Why it is secure protocol? We have used your Bluetooth devices. The first thing is we have to pair it. That pairing decision is made by the user, right? Only if we decide to pair, that happens. So it is called as secure protocol. But even there you have a chance of eavesdropping and attacking. We are not going into that concern, right? Okay, it is a short range, low power, low cost wireless transmissions between your electronic devices. Okay, what was the range of the Bluetooth device? Yes, it is a B2B network. Yes, it is a B2B network. Mm, that is one-to-one connection. As you have given, I added one more point. It is not only uh, B2B network, you can also form topologies like star topology. That is one, you have one master and you can have multiple slaves. That is, you can connect one to many devices. We see that. You have, it is an example of B2B network. It is not B2B network, it is point-to-point network. There is difference between B2B, point-to-point network. Okay. So the range of the device, it is decided by the class of the Bluetooth. If it is class 1, it can have cover up to 100 meters, which we normally don't use. When we have to cover 100 meters, we prefer your Wi-Fi. We normally use class 2 in our mobile devices. You have your class 2, right? How it is connected to, yeah, we will come to that point. Class 3 is the lowest range that it can cover only 10 centimeters. Okay, how it is connected to specific device? What will happen means, when I want to start a communication, first a Bluetooth device will inquire, right? In your mobile, you have Bluetooth option, right? You just on it, right? What it will find means it will find what are all the nearby devices available with Bluetooth. That is inquiry, and it will get their name and address, and it will display for you, right? That is the first process, inquiry. Then if you want communication, you want to pair it. Pair it means you have to establish a connection between them. So you will pick your device which you want to communicate, right? Then the one which initiate the communication will become the master, and the one which accept the communication will become the slave. Now the communication will flow in one way, that is from master to slave. It will flow in that particular way, right? When this communication happens, you have different modes that we will see in the next slide. Is it okay how the communication happens? Connection establishes. This you can simply check it in your, you could have used your share it, right? In share it, what you do, if you want to share it app, you first start, you start your if you want to send, you ask your neighbor to on their Bluetooth, then their device will be identified, you click it and you pass the information, right? And you have Bluetooth headset, right? You first pair it, then only you can work on it. Okay. How the, okay, that is the low range communication. That is, you have it operates in 2.4 gigahertz. It uses time division multiple access. If you have 4 to 5, if only you can connect up to 7 slaves, that is 7 devices can be connected, and it uses your time division multiple access. That means the same frequency range you will be using, but it is splitted for different users. At first second, the first user will be used, at second the second user can transmit if it is more than one user, right? Mm. Are you asking that way of communication? Is your doubt clarified? Sundar Ganesh, is it your doubt clarified? You are asking about signal transmission. Okay. See, I couldn't get you the point. What you mean by the signal transmission? Okay. Oh, I tell you a simple example. You were standing over there, right? There were two persons standing at a distance of 10 meters, right? If the person A and person B, if person A speaks something, then that could be heard by person B. How it happens means the sound waves transmit in a frequency that could be heard by, sensed by the person B, right? If the same thing, if person A is standing and person B is standing some say someone at at a distance of 1 kilometer, then if person A speaks, is it hearable by person B? No, because the sound wave frequency cannot be reached at that distance, right? That is the coverage, you call the coverage range of the signal. In the same way, the coverage range of your Bluetooth is 2.4, the frequency is 2.4 kilohertz, and the range it covers is from 10 centimeter to 100. I go back to the previous slide. It covers from 10 centimeter to 100 meter, right? Okay. Now, only if the devices are within that range, I can identify. How do I identify that is a Bluetooth device? Means that has to pass its signals, that has to sense its address. Then only I can identify there is another Bluetooth device. And when I couple with multiple devices, I want to serve with multiple device, means what I do, I use that frequency range in a time division axis. That can multiple Bluetooth devices be connected to the same device for same operations? Okay, that is you, if person A is transmitting, right? If person A is transmitting, that transmissions can be received by more than one person. You can receive the information transmitted by A through more than one person, but at a time you cannot transmit more than one person cannot transmit information to one person. That is, that can be one to many, but there is no possibility for many to one. At a time I can send information to many persons, but I cannot receive information from many persons at a time. This is the answer for your question. Okay. Uh, and is it okay? Okay. I'm not getting the response. Okay. Um, Sundar Ganesh, are you still having doubt? If it is so, you can unmute or give your response.
Hello, ma'am.
Yes. Yes, I'm hearing you.
Hello,
Yes, yes, you are audible. Yes, you are audible.
ma'am. As you said that when you speak in some public place, it will reach the person, ma'am. But my question is, how that signal reaches the specific device, ma'am? Suppose if we send that EMF wave by which we
Okay.
send that
Yes.
data, then
Okay.
how it reaches the specific?
Okay, that is what pairing. Okay, and now I got your point. That is what pairing. See, I show you. See, this is the three phases of connectivity. The first is inquiry. When you on your Bluetooth device, right, you're trying to find any within that range, right? Within your range, there is any other devices sending their transmission. Each device will have radio, that is they will have antenna for sending and receiving signals, right? You
Okay.
have antenna to send and receive signals, so you just see whether same kind of frequency is existing on the nearby. If it is there, it will show me, it will list out me, right? Then the next stage is your connecting, that is you establish a connection with the device. How you establish connection means each physical device that enters into a communication will have a unique address, right?
Okay.
Even your Bluetooth device will has a unique address, 48-bit address. I will show you how to find your Bluetooth device address in your laptop. I will show you the demo. Similarly, you can check it in your mobile phones. It will be present in about phone, or it will be in your wireless network. You can check what is the Bluetooth address, right? So it will pick the address, and this address, like your MAC address, it is a unique address, right? If I uniquely identify a person, I can further pass information, right? In the same way, I will uniquely through the address I identify the Bluetooth device, and then I start passing the information. The passing of information is through your way, it is through the frequency bands, and the method you use is your TDMA. Am I
Okay.
answered your question?
Yes, ma'am. Yes, ma'am. Thank you.
Okay. And this information related to your Mac, I thought I will take it after your connectivity protocol, but now I decided I will take you the Mac protocol in the next session, right? So you will have a you can understand how the informations are passed in the wireless medium, not only in the wireless medium, how the informations are passed in the physical medium. So in the next session I will take you the MAC protocol. When we take MAC protocol, we will see what is FDMA, what is TDMA, right? So you can understand how the signals, or how the waves are used to pass your information, right? Okay. Now uh, let me show how to find the Bluetooth address of your device. I will show for my laptop. I most of the time Okay. Nowadays, all your laptops are having Bluetooth support, so you can find it easily. Okay. First, I open my device manager. Is my screen is shareable? Are you people able to view my screen? Yes. Okay. 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 Fine. Okay. See, there is one Bluetooth in the device in your, if you go for your device manager, I have Bluetooth. This adapter is actually my Bluetooth device. Go to its properties. Click the advanced. See, this is the address 1 2 3 4 5 6. Okay, this is the actually 8 bits for 1 byte, right? So your address is represented as 6 byte hexadecimal value separated by colon. See, you have 6 byte separated by colon. So this is my 48-bit address. This is like your MAC address. It is unique for each devices. From this MAC address, you can identify who is the manufacturer and who is the device. Actually, you have a pattern, you have a hierarchy for this address. We are not going into that depth, but because that is not our area, that is not our concern, that is out of our scope. So this is what the address. This is how it uniquely identifies the Bluetooth device. Every it may be your mobile, even if you have a wristwatch having Bluetooth capability, that will be having a unique address. That's using that address only. You cannot change it. It is unique. It is provided by the manufacturer. You cannot change it. There are ideally speaking, you cannot change the unique address, right? When connecting to network, there are some options. I'm not getting into that, but as of now, you cannot change it. Okay, right. Now I'm just okay. As I open, I will also show you for the file transfer protocol. What you have to do is you click your computer. You have one add a network location, right? In this network location, uh, you can give the, see, type the address of the website or FTP site or network location. Here you can give the address of the file server which provides you FTP support. If you give here and click next, it will ask for user and password, right? There are some anonymous file server protocols or that you can give and access it. And even in our college you have file transfer protocol for I don't remember the address. You can give it and check it, but that is to local network. When you are within the college, you can access that. If it provides internet support, then you can access from anywhere using your file transfer protocol. Okay, with this I am resuming back to our presentation. I think I stop here. Okay. Now, so we have seen it already, connection. Okay. What happens after getting connected? After getting connected, it may be continuously active, or it may take any of the following modes. Active mode means it is regular. That means it periodically transmit and receive information. Sniff mode is your power saving mode. That is, get into sleep and then it will come back and listen for every 100 milliseconds whether I'm getting information or not. That is your power saver mode. Hold mode means it is temporary power saving mode. That is, uh, for periodic interval of time it will get into your sleep mode, but the master can retrieve it from the hold mode. Park mode means it get into the sleep mode, not infinite interval of time. Only when the master sends the command, it can get into the active mode. These are the four modes of connection supported in your Bluetooth devices. Okay, how the network is formed. Generally, you call your Bluetooth network as piconets. Actually, it is mainly used for your personal area network. And it uses a master-slave control. That is, it master means who initiate the communication. The device which initiate the communication becomes the master. There is no special difference between that. So a master can connect up to 7 slaves. It can have up to 7 devices getting connected at any point of time. It can a node cannot be more than one master. Okay, and that a device can be a slave in one piconet and master in another, but cannot be master in more than one piconets. Your piconets is nothing but, see, this is what your piconets, a master getting connected with the other nodes for passing information, right? So if two piconets can join together to extend the range of communication, then the node in between you call it as the bridge node, and this network you call it as scatter net. And again, you have its own protocol stack. We are not going to discuss all those things. Okay, what is BLE? This is low energy Bluetooth, and it is used for IoT because of its low power consumption. The applications that make use of battery can run for 4 to 5 years if it uses your Bluetooth. One such product is available in the market. I picked this example from the Amazon. This is health tracker. This is the fitness tracker, and again it has the capacity to make calls and connect calls. If your phone is if you install the app in your phone, and it supports your BLE, then you can make calls and attend calls using this device. It can be, it is like your wristwatch. Okay. Uh, like your Bluetooth, it also operates in 2.4 gigahertz. What is the different means? It always remains in the sleep mode. Only when you initiate a connection, it gets into the active mode. And it has a high data rate of 1 megabits per second. Okay. These are all the applications where you can use your BLE. Okay. Any questions? I just stop my present. Bluetooth versus Wi-Fi hotspot connections. Yes, okay. I get in. We will see Wi-Fi in the next classes. But as you asked, I tell you what is difference between your Wi-Fi. Okay, your Wi-Fi you can connect with more number of devices, right? And then here you have a master slave communication. It is not like that in your Wi-Fi, right? And then it has a high range of communication, right? And you can list out many benefits for your Wi-Fi. And actually, your Wi-Fi has physical and data link layers, and it uses the application's high-level layer for further processing. We will discuss elaborate about your Wi-Fi in the next session. Your Bluetooth is it is the basic thing, and actually you have some line of sight problems with your Bluetooth, that is not with your Wi-Fi. The range of your BLE. Okay, you want to know the covering range. That is the it comes under your class 1. Okay, it's good. It comes under your yeah, it comes under your class 100 meters, right? Okay, is bridge mode or a master or a slave? Okay, it cannot be a master because I have not, I'm not sure, but I think that it cannot be an master. I will check it and get back to you, but as of my understanding, it need not be a master. Okay, if there is no questions, I will just stop presenting.